Hello everyone and welcome to another session in IBDP MAI HL SL course, and today we are going to cover this topic 3.4 in geometry and trigonometry, in which we are going to study circle, arc length, sector and segments part. Okay, so basically we will start with some definitions and we will discuss questions on this as well. For SL part, they will give angle in degrees, not in radians. But okay, I will discuss both things, right? You must understand the difference between degree and the radian measurement for angle. Actually, pi radians makes 180 in degrees. Okay, that's the relation between these two. So if angle is given in pi or in radians, you can always convert it back to degrees, or if angle is given in degrees, you can always convert it back to radians. Okay, so 1 radian, you can also use your GDC. Make sure that your GDC is set on that particular function. Whether if the question is given in radians, so use radians, degrees, so use degree accordingly. So 180 degree, 180 over pi degrees is the value of 1 radian, where pi is what? That 3.14. So it comes out around 57 degrees. Okay, and 1 degree is also same as writing pi over 180 in radians. Okay, so if you are doing it with hands, you can use these, or otherwise you can use your GTC functions. Okay, now, the next thing is about the circle. So, circle, its circumference and radius, right? So, if you have a circle, then from the distance, the distance from the center to any point on the circle is called radius, right? And twice of the radius will become your diameter, right? If radius is r, diameter is 2r. The boundary, this boundary is circumference of the circle, which we already know. What is the circumference of the circle? It is 2 pi r, where r is the radius. Okay, and area of the circle, that is the circumference, and area of the circle is given by pi r square. So we will use these terms to get the areas of sectors, segment and all. Okay, let's discuss this. Consider that there is a circle having the radius as r. Okay, now what I'm trying to do is I'm going to take arc of this circle. So for this complete circle, whose circumference we already know is given by 2 pi r, consider an arc of it. Okay, so this having this area pi r squared we already know. So now let's consider, for this circle we are taking this much length. Okay, and corresponding angle is theta for that. Okay, so this total makes a 360-degree revolution, right? This total is 360 degrees. Okay, now corresponding to that particular point, we will get some arc length, we will get some I'll show you. Consider that we stopped at some angle theta, and this portion on the circumference having the length s. Okay, so this is arc length, s is our arc length. If we make one complete rotation, it makes 360 degree, but this time we have only theta. So using the unitary method, we can always find the arc length. What is that? Arc length can be given by total is 2 pi r corresponding to 360 degrees. Okay, so whatever be the angle is given to us, take theta over 360, that will be your arc length s. Simple. But if angle is given in radian measurement, this is for degree. Okay, for degree, use this. As I said, I'll give you both representations. 2 pi r, if the angle is given in radians, so you have to use theta over 2 pi for the radian measurement. Okay, so now let's talk about the second part. Second part is for this complete circle having the area as pi r squared. But for this arc, we have this portion which we call sector. Okay, we can take out this part, cut it out, we will get this thing. Okay, so here if we cut out that part which is making an angle theta, again the radius is r. Okay, radius is r, so this qp is called arc length. This area inside this formed by these radii and the arc length, this blue portion, this is called sector of the circle. Okay, S was this, let's call it AB. So that was arc. Okay, now same as the same we can use the unitary method to calculate the area of the sector. What is that? Take the total area, right, and corresponding to that theta over 360, pi r squared times theta over 360 using the unitary method. Okay, same as if angle is given in the radian measurement. So what do you have to use? Pi r squared times theta over 2 pi. If the angle is given in radian measurement, 2 pi r into theta over 2 pi. 2 pi cancelled by the way. So r theta is the answer in that case. Okay, let's solve some questions on that. Consider that there is a circle having the center O and A and B are any 2 points lying on the circumference of the circle. Let's join them. So AB, what is that? AB is called a chord. Here, this AB is chord of the circle. Okay. Now let's join AB to the center. A and B points to the center. So we will get a triangle, right? So here, this portion, only this part is called segment. Segment. So in this case, if this is the angle, smaller angle, and the larger angle is what? In this case, it is 360 minus theta value. So theta is smaller. So corresponding to that, the segment that we are getting is called minor segment. Okay. And the remaining portion is called major segment. Okay. So this portion, which is the remaining part, all this one is the major segment part. Okay. Remember this thing. Now, how to find the area of this minor segment here? So in order to find the area of this minor segment, what you can do is simply take the area of that minor sector. We already know from the previous part how to find that, pi r squared times theta over 360, and subtract the area of triangle AOB from it. So if I subtract the area of this triangle from that, I can easily get the area of minor sector, right? And area of triangle is given by half AB sine theta, or you can use half length, half times base into height. That will depend on the question, what information is given to us. Okay, so half AB sine of the angle between them. What is A and B? A and B are these side lengths, and in this case, these are radii. So this is R, this is R. So in place of that, you can simply write AB as R squared. So finally, pi R squared theta over 360 minus half of R squared sine theta, where theta is the angle, right? We already know theta, we already know radius, so we can find the area of the minor sector in this way. Find the, okay, one more thing about the area of major sector. How can you find the area of major sector now? Area of major sector is given by that pi r squared minus area of minor sector, that was pi r squared times theta over 360 degrees. And for area of major segment, you can use pi r squared minus area of that minor segment, right? Which we already know, this portion comes here, area of minor segment. Make sure that you do not get confused in segment part and sector part. Okay. Now, next thing is finding the length of arc AB. Yes, they are saying find the length of the arc. Means you just have to find this value only, arc length. So we have the radius, we have the angle. We can simply use the formula, which is 2 pi r, which is 6, times theta over 360 because angle is given in degree. So 55 over 360. Simplified, that's the value of your arc AB. Okay. So what is that? Use your GDC. Okay. Arc AB comes out as 2 times pi times 6 times 55 by 360. That comes out as 5.759. So 5.76 I can write that. Okay. So this much is the length. Now if this says find the perimeter of the sector for the same problem. If this says find the perimeter of the sector, that was the arc length only. But if this says perimeter of sector for same sector. So what do you have to do? In that case, you have to take that arc length 5.76 and add these radii lengths to it. Because for the perimeter, you have to include all these. Okay, so 2 times that radius which is 6. So that's your value. Okay, so if I add 2 times 6 to this value, I will get 17.759, which is 17.576. Okay, next part. Here, in the next part, it says find the area of the sector where the angle is given as 110 degrees. The radius is 10. So simply use this area is to be calculated, which is a area of sector. So what we know, pi r squared, which is 10 squared, pi r squared, then theta over 360, which is 110 over 360. Now simplify this value, get the answer. That's it. It's simple, right? 5 times 10 squared times 110 divided by 360 gives me 95.9931. So I can say almost 96 is the value. Okay. Next question. In this diagram shows a metallic pendant made out of 4 equal sectors of a large circle of radius 9 centimeters. So this larger part, this is 9 centimeter, and smaller circle, right? 4 equal sectors of a smaller circle of radius 3 centimeters. So OA, or you can say simply this portion up to this is 3 units, 3 centimeter. The angle is BOC is 20 degree. So this angle BOC is given as 20 degrees. Now find the area of the pendant. So in the pendant area, what we have actually? We have this portion and the portion inside the circle. All these 4 sectors plus this. So what can I do? Can I take the area of the circle and add the 4 times of these sectors? Is it the answer? No, that is not the answer. Why? Because we calculated this portion twice. If you do that, you are adding that smaller portion twice. So don't do that. Okay. We need to remove this part. We have to count it once only. We cannot count it twice. So for that, first let's calculate the area of this complete circle. What is that? It's a circle with radius 3 centimeters. So pi r squared. Okay. So pi r squared, which is pi 3 squared, is the area of the complete circle. Now remove these 4 sectors. Okay. 1, 2, 3, 4. 4 sectors needs to be removed. So each have angle what? 20 degrees. So simply use pi r squared into theta 20 over 360, which is this. Okay, so this is 9 pi minus, when you simplify it, what do you get? Times 4 also, because these are 4, right? So simplified 9, 4 to 2 pi. So area, the remaining portion of the circle after removing these 4 sectors, that part is 7 pi. Now I will add these 4 sectors, these 4. Okay, so I got 9 pi minus 2 pi, which is 7 pi. Now 4 times the area of these four sectors making an angle 20 degree, having the radii as 9 centimeters. So again 4 times I will add 4 times pi 9 squared times theta, which is 20 over 360 degrees. Just simplify it. This value comes out as 18 pi, and when you add this 18 pi to the 7 pi, you will get your answer, which comes out as 25 pi, or when you put pi as 3.14, it is 78.54 centimeters squared value. One more question. On a golf course, the grass is carefully watered to make sure that the grass receives neither too much nor too little water. On a certain area of a golf course, the lawn sprinkler is set to spray an arc length of 150 degree with the maximum spray of 3 meters. Okay, so let's draw the graph first. Then we have to calculate the area of the grass that is watered by this sprinkler. Okay, can you see there is a sector in this case, right? It is rotating from that 150 degree. It is only covering that 150 degree area for that circle, right? And the radius is 3 meters. So let's draw the graph figure first. So as you can see, this blue portion represents that portion which is watered by the sprinkler over here. Okay, so angle is 150 degree, radius is 3 meter, and sprinkler is set at the center of the circle over here. Okay, so what we are trying to find, we are looking for this area. It's simple, right? We just need to use the formula only. So the sprinkler is set at 150 degrees, so it will cover this much of the total area. Okay, so simply use pi r squared theta over 360 means pi times 3 squared times 150 over 360. On solving it, we gets 11.8 meters squared or 11.8 meters squared as the area. Okay, so in this session we covered finding the arc length, finding the perimeter of the sector, as well as finding the area of the sector, and if needed we can also find the area of the segment. I already gave you the method. Find the area of sector, subtract the area of triangle. uh, uh, Once we are done with the trigonometric function, because I have to cover that sine theta cos theta thing first, which we will do in the next session, by the way. After that I will take the questions related to those segments, because we are going to use the sine rule and cosine rules to get those values. Okay, so that's it for today now. Thank you for watching this. See you in the next part. Keep watching, keep learning.